Hello, everyone. Today is Saturday, February 14th. This is week 15, day 4 of India evening and weekend platoon. Today, we're going to cover language parsing, continuation of our AI ML unit. Um, Thursday, we covered text pre-processing. And what's the main gist you should have learned from text pre-processing? We need to do what to the data in order to train our LLMs?
Clean it.
Yep, clean it. That's the main thing you should have learned from Thursday's lesson. We need to clean it. And I made a specific reference to training LLMs, but all data that you receive, and this is really important, all data that you receive from a third party into your company will have to be cleaned, or at the very least, validated. Does everyone understand that? Because it won't come perfect. You'll pay for something, or a company, not you, but your company will pay for something, and there will be flaws in that data, right? So it'll be up to your company to clean it up. And keyword here, the main thing for today's lesson, organize it, which is the key thing we're going to learn today. Organize that data into usable formats for your company specifically, or the use cases that your company has. Does that make sense? So if Thursday was about cleaning data, today is really about organizing. So with that, we can get started. And I'm actually going to start with Thursday's example once again. So we can get this. Do you see my screen? Make sure everyone's
Yep.
in here. Okay. Okay, cool. I'm going to move this over here. Make sure I don't get it lost. All right, I think we're good. All right, cool. All righty. So we talked about second. Thursday, the importance of text preprocessing, just cleaning the data, and the importance of that not only for LLM models, but just for pretty much every use case in software engineering. Clean data is good. It tends to not break things, and we like that. So today's main lesson is about language parsing, right? And I know uh, we talked a little bit uh, about this on Thursday. So we're just going to go ahead and continue with this. What makes up a sentence in English? Just give me the very basic components.
Words.
A little more than that, that's useless, Brian. Think English class.
Subject,
There
object,
you go.
verb.
There you go. Subject, object, object, verb. Perfect. This is the blueprint of pretty much any sentence, right? Yes? Let's go with the example in the lesson, actually. The cat sat on the mat. The cat sat on the mat. What's the subject?
Cat.
Awesome. What's the object?
Mat.
What's the verb?
Sat.
There you go. There's a blueprint of this sentence. And this is really, really important because it kind of starts to tell the LLM, right, kind of the blueprint of all sentences so they can understand them, right? So this is really, really important because ultimately, and we're going to talk about this a little bit later, it starts structuring and organizing the data, right? It needs to know the blueprint of sentences. So when it takes an input, right, it can organize the data in that manner. So there you go. Pretty simple. Okay, language parsing is just understanding the basic structure of an English sentence. We can go to the lesson here. I kind of hate this picture. This is really hard to understand. I would kind of ignore this, honestly. Just ignore this picture. The main gist of it, you just have to understand that organizing the data is really important. That's it for right now. So this gives you kind of the definition of natural language processing. Just refers to the process of analyzing and breaking down text or sentence into its grammatical components to understand the structure and meaning. I don't know why I deleted this. The cat sat on the mat, right? To understand the structure and its meaning. I've also identifying the roles of individual words play, such as nouns, verbs, and adjectives, right? And sometimes also injunctions. Anybody know what an injunction is? You see it on line 3 here. Or things like wow or cool. Uh, just stuff like that, right? It's stuff that doesn't really, I mean, it doesn't really add any kind of clarification or understanding to a sentence, really. Uh, but it's English, so we need to know what it is. Um, Alrighty, so this is kind of what we're talking about, figuring out the blueprint of all the sentences, and all the sentences in English are written in this manner, right? If I say, hey, check out that giant blue Pokemon, right? What's Pokemon?
The object.
Yeah, Pokemon is the object, but so what's this though?
Adjective, adjective.
Yeah, absolutely. These are just adjectives of this subject, Pokemon. Do they add anything to Pokemon? Well, what is it describing?
Size, color.
Yeah, size and color, right? So in terms of organizing data in a really like oversimplified way, right? This, right, would be tagged as, hey, this references Pokemon, right? But it'd be ordered in a way where what's the most important word here? If this was chunked together, which is a key word here, right? What's the most important word of those three? That's not a trick question. Look at those three words. What's the most important word? It's typically always like the key part of an English sentence. So what's the key part of the English sentence here? Pokemon, right? Yes. Hope that makes sense. All right. So when it came to actually organizing Pokemon, the subject would be the most important thing. Yes, this is helpful, right? But this without this still makes sense. That sentence makes sense, right? But if I did this, uh, that'd be really hard to understand, right? That giant blue, I don't know what that is, right? You just did two adjectives of a missing subject, it looks like. That doesn't make sense. Not to a human, not to a machine. Alrighty. So language parsing, right? Just this idea, synopsis just here. Yeah, I'm not going to read the whole thing. It just says, hey, what's the blueprint for English sentences that you want me to understand? And that's all this is. Perfect. Then it goes into this lesson goes into reviewing regex methods, but we're not going to review regex methods. I expect you to already know them or be able to look them up. This just talks about just a review, searching a string, finding all instances of something in a string, right? Um, any questions about regex specifically?
Where do you find that it's most used in production code?
Fantastic question. Um, input validation, always input validation. And no one ever writes it from scratch. They just literally just copy paste it from somewhere and edit it. That's how they used to do it. Now they probably have AI spit it out and then they validate it and we're good to go. But no one ever writes, even back then, even like 10 years ago, they didn't write it from scratch, right? They just found some hero on Stack Overflow that wrote it and then they tweak it for their use case and ship it. That's where you see it the most, right? But you also have some, here's where I see it a lot too. Um, in PII identification, right? Large language models will identify something like, I'm just making this up. What does this look like to you? Line 16. If I was talking about personal identifying information, what does line 16 look like?
Social.
Yeah, like a social, right? So you get it to, hey, do a match of people's socials and either like blur it out or like eliminate it or replace it, which is really, really famous. I forget the word for it. So when something is stored somewhere, it'd be hashed or just look like that, right? When anyone sees it that doesn't have the permissions to see it, right? So we can tell, hey, oh, this is screwed that up. Hey, this is a social, but you're not privy to that information, right? You see it in healthcare with HIPAA a lot as well. Addresses, social security numbers, medical conditions, right? Which is regulated federally in this country, very tightly, right? Make sense? Like when I take my dad to the doctor, like I had to like fill out a bunch of forms just so I could like schedule his appointment to get his medical records. But my dad's very elderly and sickly, right? Like I need to be able to take him to his appointments, figure out what the hell's wrong with him, make sure he's taken care of. But there's a bunch of laws governing that data. Make sense? Great question. All right. So regex stuff, that's where you're going to see it a lot. Not going to go into it. It's import the library and then play with it. It's pretty straightforward. Part of speech, this is tagging. We mentioned this on Thursday, so I'm going to go ahead and jump to that example here. Here we are. What do you think this would be tagged as? What I just highlighted.
A good time.
Yeah, right. Is this all referencing one thing?
Yes.
What's it referencing?
The 30 pack of beer.
Yeah, it's just referencing beer, right? Right. So this part of speech is really important, right? That the machine understand that, hey, this is going to have to all be grouped together, that it's referencing beer, right? Keystone hopefully can identify that that's just a brand name. You can replace this with anything. And this is just a quantity, right? So there's a lot going on here, right? But if there's some kind of metadata tags, that's how it would be tagged, right? And then ultimately it would be organized in that manner. What's the most important word in the highlighted right now section? What's the most important word? Think parts of speech like we were earlier. It'd be the keystone because it's the beer, right? If I just said 30 of something, well, 30 of what? I don't know. There's 30 of them. Incomplete. But if you say, hey, beer, okay. I understand what that is. Still missing the quantity, but it makes more sense, right? Part of speech. In traditional grammar and LLP, part of speech refers to the category of word belongs to based on its role in the sentence. While there are many fine-grained tags, right, they map to 9 core parts of speech to form the foundation of English grammar. We talked about nouns. Pronouns replaces a noun to avoid repetition, things like he and she, they, it. Where do we see this? Noun is easy, right? When I gave the example of the cat sat on a mat, you know the cat is a noun. A pronoun, he, she, they, it's not always that cleanly, right? It could be something like on line 3. Could be something as easy as bro, right? They didn't teach you that in English class, did they? But it could be, right? A verb, super important. Adjective, we talked about blue large. I think this is, I was reading this earlier. I think that's where I got the blue large Pokemon from. Adjectives, adverbs, modify verbs. These are just parts of speech. I'm not going to go into it. Just know that, hey, in POS tagging, all of this matters, right? Because the actual blueprint of the English language, the machine needs to understand, right? All right, so this is probably one of the most important pieces here. So I will read that first sentence there. Part of speech tagging, right, is a process of labeling each word in sentence with its grammatical role, such as noun, verb, adjective, or adverb, based on the context and function within the sentence. This step is essential in LLP because it helps models understand the structure and meaning of text, supporting tasks like parsing, indent recognition, and then lemmatization that we discussed on Thursday. What is this saying here? If I told you to, hey, can you summarize this in just one short sentence, what would it be? POS tagging is really important because it does what?
Helps the model understand the way we speak.
Yep, that's it, right? And you see it here. Without our ability to do this properly, right? This sentence becomes impossible to decipher for a machine. And why is that? Can anyone tell me?
I think if you don't know grammar, it's just word, 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 with no context or relation to each other.
Exactly, right? What's the subject of the sentence, right? What's the verb? Is it acting on something? Is it doing something? Is it going somewhere? Is it sitting on something, right? Is it expecting something? Is it a question? Is it a statement? Is it an order, right? It doesn't understand any of that, and all of that matters, right? So the process of labeling each word in the sentence and its grammatical role, right, based on the context and function within the sentence. Super important. Then right here, it goes into goes into applying these tags, right? But you already did this on Thursday. I'm not going to go into it, right? And then you'll have your little output, right? This list. Breakdown of QoS abbreviations. Again, you can read them. Not gonna go into them. Just understand that the parts of speech matter because ultimately, right, what the model is going to do is, well, you kind of have to do it for it initially, is order, right? Put order to all of those words, right? I haven't taught you this directly, right? But think of all of here. If you think of the nine core parts of speech, I don't even know there was that many, right? In English grammar, and you had to order them in terms of importance, what would be the most important one? It's kind of an easy question because they kind of put it in order a little bit. The first one. Why is the first one the most important part?
Probably because most words are nouns.
That's part of it, but also that's the crux of the entire sentence, right? The sentence is about a person. It's about a place. It's about an idea, right? Has to be about something like that. That's the most important part, right? And the models need to know that. They need to know, hey, this is how we structure our language, right? Go ahead and organize it in this manner, right? Yes? Look at these 9 core parts of speech. Look at them. They grow to be less important as you go down. Think about it. Noun, pronoun, verb, adjective, adverb, preposition, conjunction, interjection, delimiter. If I cut this out, cut 4 through 9. Can you still write sentences? Absolutely. Right? Let me give you an example. Guillermo ran very fast. Guillermo ran very fast. Guillermo ran fast. Did I get my main point across? With Guillermo ran fast? Didn't need the very, did I? Guillermo drank a beer. Guillermo drank a cold beer. Don't need the cold necessarily. Guillermo drank a beer is enough. Cold tells you the temperature of the beer, but my sentence, Guillermo drank a beer, still makes sense. And I got the main point across. Yes? And you start kind of looking, right? That what does this look like based on Thursday's lesson? A lot of these words down here start to kind of look like what? Focus on 6 through 9. Filler, nice job, Yi. And stop words that you don't need to still make sense of the sentence and what the intent was and the context of it. Very good, Yi. Nice job. And don't need them. And they can still make sense. If used properly, can they add to the quality of the training of the model? Absolutely. Yes. Right. But initially you start without them. right? I won't get into it, but then eventually you start to like fine tuning already trained models or whatnot to get more optimal results, right? But have you guys heard me say that refactoring is for closers? Have I said it in this class yet? This happens a lot actually in these classes. This happens in personal projects a lot. Like you guys will have like these big ideas, you start building, and then I'll jump into some breakout rooms and they'll discuss the ideas. And people will tend to hyper fixate on, the color of something, or they want their app to do this or whatever, but their app doesn't even work. I was like, get the minimum viable product, get your CRUD, get your 3 APIs, make sure it works. It doesn't matter if it looks like crap. Like, can you pass the assignment? All right, cool. After you can do that, you can hyperfixate on whatever it is that you want. You have a passing grade, right? You have a minimum by an MVP. Happens a lot, right? So initially, you can train the model without these, right? And this comes right at the end. But in reality, just fill it. Don't really need them. Can you explain that, Logan? I don't understand that. I never watched a lot of Dragon Ball Z, so
Oh, just when you like said filler, like filler episodes in your favorite
yeah,
show.
yeah. Hey, that's a thing, by the way. I just recently learned that, probably in the last year or two. Like,
It's huge in
what?
anime. Yeah,
Yeah,
you've
what
been
do they
watching
call?
300 filler episodes of Naruto.
They call them like bridge episodes, right, or something like that.
Yeah, that's what they like to call them. And they've got two key points, and yeah, that's cute. It's a waste of your time, so it
Yeah.
is.
Dude, this is actually kind of interesting. I think I read an article of Breaking Bad. I was always a Breaking Bad fan. But I think they talked about one of the filler episodes that they made. It was like budget constraints. They ran out of money. So the next episode to close out the season or something, they had to make it uh like super cheaply. So I think it's like one of the episodes where like nothing. Oh, I remember. It was the Fly episode. Anybody watch Breaking Bad? No, no one watched Breaking Bad, really?
Yeah, everyone watched Breaking Bad.
Okay, okay. If you remember the Fly episode in the lab, that was the episode. How the entire episode is around the fly that is like a toxin in the lab or whatever. That was the bridge episode. I mean, I thought it ended up being a good episode, right? Yeah, yeah, that was it. That was it. You got it. So that was a filler episode. Anyway, we're getting off topic here. But yeah. Anyway, filler episodes. I don't watch anime. I didn't know anime had a problem with filler episodes. 300 is too much. I hope you were exaggerating. All right, cool, cool, cool. Parts of speech. Just understand all the parts of speech, but just remember, really, it's the main important ones uh, that are really important. Here's something we don't really think about. Remember, I said that I was talking about like refactoring was for closers and fine tuning LLMs, right? You can start getting into 6 through 9, right? Initially, you just start here, right? Initially, you don't start with all of this simply because it's going to be really, really expensive. Right. So you're going to notice a lot of the libraries that we use, right? Just for these intro lessons, you end up getting rid of a lot of these and you won't even use it. You end up just tokenizing just pretty much, and maybe really just a lot of it is just the first three, right? Uh, yeah, but that's okay for an intro lesson. All right. This goes into the POS abbreviations, which I'm not going to get into. They'll be in your homework assignment. Chunking techniques. This just talks about chunking and natural language processing, refers to the process of grouping individual tokens, usually words, into larger meaningful units called chunks. These chunks typically represent phrases such as noun phrases, verb phrases, or prepositional phrases, while a part of speech tagging labels each word with its grammatical role, noun, verb, etc. POS tag tokens into coherent segments like the new textbook. Why is this chunked together here? We're talking about chunking words or chunking sentences. Why is this chunked together here? Just the obvious answer.
All related. It's probably the object of the sentence.
Yep, that's it. It's all together, right? It's all referencing textbook, which is the key word here, right? The doesn't really add anything, right? New is an adjective that describes the textbook. That's fine, whatever, right? But textbook's the key word here, but it is all together, right? So in simple terms, chunking helps identify and extract small structures that represent parts of the meaning within the sentence. The example they gave is the new textbook. That's a good example, right? It's referencing a new textbook. So why is chunking an important step in natural language processing? It helps capture phrase level structures rather than just word level details, enabling deeper syntactic and semantic analysis. This is really important. Why do you chunk these together? Why do you chunk words like line 7 together? The answer is right there. Just give it to me in plain English. It all references one thing, right? That's why it's grouped together. It's just referencing one thing. And it's understood as it being together. Rack of cold just refers to cold beer. That's it. This is actually kind of hard to understand. I'm just going to leave it as many of the language processing tasks rely on phrase level understanding, right? Just this idea that, hey, some of these things can only be understood together, right? Like rack of cold ones or a 30 case of Keystone, right? They can only be understood together. That's it. That's the only thing. Chunking reduces complexity by organizing sequences of tokens into higher order units, making it easier for models to process relationships in patterns, right? The only thing that says that is if Thursday was about cleaning data, today is about organizing, and it would organize, right, these chunks of data, right, in order. Like, for example, Keystone is the most important word in this little phrase. So if it was chunked together, that's fine. But Keystone, it would be a reference to the beer. And then all of these would be less priority words, like the 30 and the case and the Keystone, right? The case is interesting, right? Because it tells you kind of what it is, right? But this could have been, six pack. It could have been anything, right? The important part is it's a certain quantity of beer. Gonna skip that. Not important or just too much. Okay, this is types of chunking in natural language processing. I don't know how much of this part you really need to understand. You just need to understand the big chunking piece, right? That hey, some of these words only make sense together, so let's put them together and let's organize them together, right? This kind of goes into the different types. I'm going to look over this, but I don't see much value in getting into the weeds of this, right? This just talks about yeah, just different types of chunking, right? Whether it's a noun chunk or a verb or a prepositional phrase. And these match what from earlier?
Was it the 9 classes of whatever?
Correct. Yep. I don't think this is 9, but yeah, it matches it almost identically. Right? Just, hey, sometimes we chunk based on this, the 9 core parts of speech. That's how we chunk sometimes. And notice there isn't 9. That's because some of this chunking, like this stuff, it doesn't really need to be chunked a lot of the time, right? A lot of the time, these words just end up being filler. They get, um, they get filtered out. But they're not adding any kind of value um, to the training. So this is just saying, hey, we chunk based on the 9 parts of speech. Just keep that in mind. That's it.
We always talk about training LLMs. Is the training just grabbing data and throwing it through these libraries, or is the training actually building the library to chunk the data?
Ask that question one more time.
Yeah, so we always just kind of loosely say, oh, training LLMs. I've never trained an LLM. Is the training just taking big amounts of data and running it through these libraries that do the chunking, or is the training actually building the libraries that know how to do the chunking effectively?
Real training LLMs is the latter, right? You're actually building it, right? Great question though. But that's more of like data scientist work, not really dev work. So kind of what I mentioned earlier in the week is this idea that, again, in your role, unless you end up being in a heavy AI ML role, you won't actually ever train models. Like I've never trained a model. I don't even know how to really do it. But you do interact now with AI pretty much every day in one facet or another, right? I told you on that project that I was working on. I'm working with a senior data scientist. He's in charge of the models, but everything else, it pretty much falls on me, like all the auth, the building out the API, the figuring out why there's a bunch of like vulnerabilities in the dependencies when we got the handoff, right? Fixing all that, documenting, right? Why we have to live with a certain dependency because this specific NPM package, right, has it, and our application can only work with that version. So we just document it and move on. So uh, it will definitely affect you in pretty much every role, but how it affects you really just depends on the role, and you won't really be training LLM models, probably. Make sense? I'll tell you like an interesting problem that I've recently helped fix. Um, like this is some of the work you might be doing too. Like, for example, there's a specific model that someone else built, right? But the way that the data was fed into it was incorrect, right? So that data processing layer, I had to go in there and fix. So I had to kind of understand what they wanted, right? But ultimately, that's not really AI ML work, right? That's pretty much just dev work. But you have to really understand how the model is reading the data so you can feed it into it that way. Does that make sense? So that processing layer is what I worked on. You might do something like that. Make sense? Oh, and in my experience, guys, data scientists, their coding's not that good because they're data scientists, you know? At least in my job, we work hand in hand if we end up on that project together. Does that make sense? Okay. Did I answer your question, Logan?
Yeah, it's just I feel like that gets loosely tossed around a lot, like training LLMs. But I was just like, well, what is it actually now that we're like kind of in the weeds?
Yeah. Yeah. We're probably not going to train them, but understanding how they work is actually really important, right? Here, I was in a meeting the other day, actually, uh, that one of the users of the application we're building was asking, hey, If we ask the chatbot for, X, Y, and Z, and it comes back with a wrong answer, can I talk to it and say, hey, it wasn't X, Y, and Z, it's actually this? Can it learn from that? The answer was no, obviously. But that was a legitimate question that people didn't understand. They thought that they could try to train the model by correcting it, right? Like I asked for X, Y, and Z. It didn't give it to me. Let me correct this model right now. Hey, it's not that, it's actually this. Can you learn from this? And they thought they could actually train it by just chatting with it. You obviously can't, but it was, I mean, that's a legitimate question, honestly. Cool. All right. So just to kind of go off with what Logan was saying, I'm going to pause right here and really try to solidify this idea that, hey, you don't have to learn everything in this lesson, right? This is a lot, even for me. And we understand that, right? But we just want to expose you to some of it because depending on your role, right, you will speak, maybe you end up seeing a little bit of language processing. Maybe you don't see any of it. Maybe your job just involves a lot of data engineering, of clearing data, cleaning data, and doing other stuff, right? But it's important to understand a lot of these concepts because you probably will be affected by them. And hopefully I gave real world examples of how I'm affected by it. You might be affected in a similar manner. Make sense? Because AI is everywhere right now. So hopefully that helps. The next part of the lesson just kind of goes into chunking and using regex parser, right? But this is just a library. I'm not going to go into it, right? And then it gives you a little example on how to use it. Conceptually, it's really the only thing I want to focus on because this lesson is starting to kind of get kind of long. I'm not going to get into the language parser thing. I told you that just a library that's going to help you do that thing. But the next thing I do want to touch on here is what is a tree? So for trees and subtrees, right? I talked about organizing, and I'm not going to go over this little section because it's kind of a lot. But the only thing I want you to remember from this specific section of language parsing and processing is this idea that an English sentence will have an order and there will be a hierarchy, right? And that hierarchy, right, will follow this. The 9 core parts of speech. This is the order. That it will follow. Remember when we went back to this and I'm like, hey, what's the most important sentence of X? I mean, what's the most important word of X sentence? That's pretty much the down and dirty on trees. It's a lot more nuanced than that actually, right? But for right now, that's all you need to understand, right? And this kind of just goes into how to implement it, right? Questions on trees or subtrees? The most important thing that you need to learn is right there. A tree is a data structure that represents how your sentence is grouped into chunks based on the grammar rules you provided. Each node or branch in the tree can represent a chunk label, a phrase, your grammar matched, or a leaf node individual tokens and their POS tags, right? Because it's taking one giant sentence, right, and it's ordering it based on the parts of speech. That's it. I wouldn't read any more into that unless you really want to, because it starts getting kind of confusing, right? You can read about trees and subtrees, but as long as you conceptually understand, hey, they're just ordering the sentences based on these 9 core parts of speech, that's good enough for now. Okay, and the last part here, I'm pretty sure that's the last part, is creating a counter to see most common phrases. In many real-world NLP tasks, such as information extraction, document summarization, and chatbot intent modeling, understanding which phrase patterns appear most frequently can reveal meaningful insights. For example, in a support ticket system, common noun phrases might account issue, login error, or payment method. In a chatbot, recurring verb phrases might help identify typical user intent, such as want to order or need help with. Creating a counter to see most common phrases. Can anyone think of why this would be important? Or can anyone think of
when you're
Go
on
ahead.
the phone with the bank automation system and you say, I want to do a wire transfer, and they say, you need help finding an ATM?
No, not like that. Uh, can anyone think of a reason why this would be helpful by chance? Or where do you see this? You see this in social media a lot, actually.
It identified trends and patterns.
Yeah, that's it, Adam. Nice job. You see this in all social media. You ever notice that when you like a kitten video? What happens after you like a kitten video?
You get
You
nothing
get
but
all the
kittens
kitten
for a week.
videos.
You get all the kitten videos, right? What happens when you return from a trip in Japan? You start getting what? Same thing, right? Cool things to do in Japan, right? All of a sudden you're getting Japan memes for whatever reason. No, it's not for whatever reason. They actually know, right? So this just goes over kind of creating a counter of the most common phrases. I won't go into it. You can use this code to kind of figure it out. But the main thing that I wanted to emphasize here is this happens quite a bit in the algorithms for social media and a bunch of different things, right? Where people they cater the algorithm to your personality, your likes, your dislikes, right? So you can stay engaged on the platform longer. Happens a lot. This is just a common way that they do it. Make sense? Here, I'll give you a very good example of this. And I know that they're doing this, even though I can't prove it, right? If I look at my search history, of on my personal computer, of everything I've ever searched for, right? I'll tell you right now that I'm sure that somewhere there's a count of my most visited sites, right? And I can tell you right now that they probably know it's ESPN. Whenever I want to check the sports on something, I always go to ESPN, and they know that, right? There's a counter back there, right? That caters that caters to me for that. Not only on all my social media profiles that they can match my email with, right? But also my browser history, right? And that's true of everyone here, right? I gave a stupid example of ESPN.com, right? But for everyone, they have that. Sorry, I'm reading the chat here. It's definitely not a coincidence, Logan. I can assure you that. Anyway, all right. Creating a counter to see most common patterns, guys. This is just a technique, right? This is just a technique in natural language processing, right? Hey, they can just count the number of times you've said a certain thing, right? Make sense? Yes. Boom, 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 boom. Code breakdown. This is just code breakdown. I'm not going to go into it. Chunk filtering. You can filter out these chunks. Also not going to go into that. There's code examples. Here, the conclusion we'll touch on though. Language parsing is a foundational skill in NLP, enabling us to break down raw text into structured, meaningful components that machines can understand and work with. Throughout this lecture, we explored how parsing works from identifying individual parts of speech to grouping words into higher order chunks. Why is this important right here? Grouping words into higher order chunks. Why is this important?
That's how the model understands.
Yeah, right. And is a noun phrase, should that take precedence over like a preposition phrase? In English, do we have a hierarchy of speech? Yeah, of course we do, right? So if we, as English speakers, right, have an order of importance in the way that our language is structured, then the model should have the same thing, right? It should understand that, hey, nouns take precedence, then pronouns, verbs, adjectives, right? And really the last thing that takes precedence is these kind of filler words or interjections, right? Because they do add a little bit of color, a little bit of context to the phrase, but ultimately we can do without if we have the rest. I hope that makes sense. Okay, grouping words into higher chunks, verb phrases, prepositional phrases. We saw how tools like regular expressions, POS tagging, and chunking with NLTK's regex part helps us systematically analyze sentence structure. Ultimately, these libraries are just helping you do what? I didn't really go into the libraries really, but they're just going to help you do what?
Organize and group data.
That's it. Nice job, Adam. Organize data. That's it. So this is important here. Parsing is more than just a technical step. It's what allows the NLP systems to move beyond simple words list and begin to grasp relationship between words, phrases, and ideas. I can't remember who said it, but someone said, if not, they would just understand it as word, 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 word. Who was that? Is that you, Logan?
Yep.
Okay. That's why it's important. If you understood what Logan said earlier about, hey, if they don't understand our English structure and the way that we prioritize not only words but phrases, right? You're not going to be able to understand the importance of certain words and how they relate to each other. Awesome. All right. Whether you're building a chatbot, performing information extraction, and preparing data for machine learning models, understanding parsing gives you the power to create systems that interact with language in more natural and human-like ways, right? This idea of data cleaning and data parsing or language parsing is actually really important. Yes, they're used a lot in AI, ML, but they're used in normal everyday dev work as well. Cool. As you continue to practice regex, POS tagging, and chunk filtering, remember, mastering parsing equips you to tackle a wide range of not only NLP tasks, just regular dev tasks too, from intent recognition to semantic analysis. It's a critical bridge between raw language data and intelligent application. That's actually a really nice sentence. That is true. Let me make sure I didn't miss anything. Natural language processing. Okay, I don't think I did. Let's go back to this and let's just kind of try to put a bow on this. Natural language processing, if you had to give a summary or a synopsis of what it is, what is it? If Thursday was cleaning data, today was about organizing, right? But what helps us organize data? What's important? That's the main lesson for today. It's language parsing, right? What's the importance of this? Come on. Maybe if that's a bad question, let's see if I could rephrase it. I don't think I could rephrase it. That's kind of what I want to ask. Why is language parsing important?
I mean, the main goal is for understanding, right?
Yes, give me a little more than that. Yeah,
Or
you're
just
right. Creating a model that, yeah, that works correctly, but a little bit more.
I mean, the name the NLP it's the process to get at that goal. So breaking it down and to smaller chunks to make it more easy to understand.
Yeah, that's all that's happening, right? But why is it important?
I think models need the input to be organized in a way that it can understand what we're actually talking about. So POS tagging, tokenization.
That's it. If I had to oversimplify it just to one sentence, it's right there on line 14. It's not even that good of a sentence, but that is the crux of the entire thing, right? Without proper language parsing, right, the machine cannot differentiate between and makes sense. Uh, I'm sure some of you probably hate this, but I do this a lot and people hate it. When someone will say something and I'll say, yeah, but that doesn't mean anything. Have you noticed I say that a lot? Because to me, you're sounding like this. It doesn't mean anything. People can say word, people can speak and not say anything at all. Does everyone understand that? You can speak without saying anything. And that's what this is, right? What I want is this. What everyone wants and what machines want is this. This means something, this is nothing. If I told you, hey, we're going to order this data, this last sentence, right? What are the two most important words in that sentence?
Drinking Dr. Pepper.
No. Try again. You got one of them though.
Likes drinking.
No.
Oh, okay, I see. Guillermo drinking.
Yes. Third time's a charm, Jose. Nice job. E
Hmm.
for effort. Does everyone understand why those are the two most important words? Notice I didn't give you any fancy tech language, right? But if I look at it and you start thinking, what's the proper way to train an LLM or what a machine would understand? Those are the two most important words. And it would be ordered and tagged in that manner. Guillermo, who? What's the most important thing in that sentence? He's drinking something. Everything else is, yeah, it's Dr. Pepper, but it could be anything. The two most important things, if I had to organize it and order it, is that. I don't want to kind of get too much into it, guys, but the reason why they organized uh the sentences because ultimately they put weight on the words. Because LLMs are just what kind of models?
Language models.
Yeah, but there's a lot of different models that that's just one kind. But you're just giving me the definition of the acronym, right? But these are just what kind of models? I say it a lot, but this is really important because it's lost on people. Don't forget that. They're just statistical models, right? So when I talked about organizing a sentence, right? They organize it because ultimately they weight the words, which is the only way that this can happen. Right? This is a gross oversimplification, right? But in this sentence, Guillermo and drinking is worth more points. Likes is worth very few. Right? Doctor, even less. And pepper, slightly more. Like if I had a good model, right, that had a lot of data and I gave it this, it'd be able to figure out that it was a Coke, it was a soda. Right? He doesn't like drinking pepper. Oh, he likes drinking. Oh, Dr. Pepper, the brand. That's a pop. I got that. Cool. Stop there. Sorry, that was, dude, a ton, man. Questions, any big macro questions about language parsing or its importance, which is really the main thing you need to remember. Notice I didn't really go into the weeds on the libraries. I don't know what you're getting at with that. Yeah, two nouns.
I was just talking about the priority, the list we were looking at earlier.
Yeah, yeah. And I know Jose, you took a couple of times, but thank you for always being willing to attempt something. Um, but yeah, I kind of don't want to get into it this way, but yeah, just look at the 9 parts of speech. I don't even remember the 9 parts of speech. It's been a long time since I've been in English class, right? But what really helps is just being in tech every day and seeing some of this stuff, right? So just kind of when I look at it, I know that that's what's happening, right? And ultimately, that's the only thing you really need to get to, right? Get to it, and then whatever job you have, obviously you cater your skill sets. But you don't cater your skill sets. You just learn it, right? You're at work smashing your face against a problem, then eventually you're going to learn it. Pretty much any job can be taught, right? At least that's what I believe. All right, so let's just wrap a bow on it now. Any questions on the importance of Thursday's lesson, cleaning data, and the importance of today's lesson, which is language parsing and its importance, right? So Thursday was cleaning, today was just organizing data. And how do you organize data? You actually have to tell the LLM how to organize it, right? It doesn't know how to organize it, right? And everything that we learned today, right? The POS tagging, well, we learned it on Thursday, but the POS tagging, the chunking, right? All of that is saying, hey, order the data that I'm about to give you in this way. Because if you order it in this way, you're going to be able to understand it. As everyone's brain fried now. Alrighty. That was a lot. This is what we want to do. Let's take 20 minutes. Oh, let me pause the recording here. All right. There's two assignments today that cover the lesson that we learned. They're pretty identical. I was kind of hoping there would be the second one be a little different, but they're not. That being said, we're all going to start with Moby Dick as our assignment. And we're going to get started individually at first, but then we'll jump into the groups to continue this Moby Dick assignment. I just want to kind of go over it briefly before we get started. Okay, so this NLP assignment, you're going to process Moby Dick with the Python library, the NLTK. You've already used this library before, so I won't delve into it. Make sure to install it, import everything that you need. So the tasks are actually laid out pretty nicely here. You're going to do 7 things. The first thing is noise removal. You're going to remove anything that is not necessary and shouldn't be there using all these regex methods. I have an example here because last time, I think on Thursday, I saw this a lot, which is totally fine. But I'm going to ask you to analyze this code here. Take a minute, analyze this code. I saw this a lot on Thursday. Well, I saw it a little bit on Thursday, actually. This code works, and it's great. What's the only issue with it? Can anyone tell me? Yeah, 3 method calls, you got it. So how would you improve it, you?
Make it into one.
Make it into one.
Create a pattern for the regex. A variable that has all 3 patterns.
Is there method chaining in regex? I guess probably.
Yes. But you don't even have to chain them here. I think you can just do it all in one. But yes, you could also chain. And someone besides you, why would you do it all in one as opposed to 3 separate ones?
It's just less code to maintain.
That's part of the reason, but that's not the programming reason, I guess.
It's more efficient. It's all done in one go instead of 3 separate calls.
Yeah, you're getting to that, but I kind of want to hit on something really, really specific here. How many times is this going through the string or Moby Dick or
Is it because each time it's making a new string?
well, that's part, yeah, that's kind of where I wanted to get at, right? So in a word, let's say this string was, oh, actually, I don't even have to create one. We have one. Let's say the string is this long. This doesn't really matter. You're doing it 3 times, yes, right? And you're recreating it 3 times, also correct. But this string isn't very long. What if this string is 1,000,000 characters? Then you're iterating 1,000,000, 1,000,000, 1,000,000, as opposed to just do it once. And you're also recreating it. Good job, Logan. You're not recreating it 3 times. Sub is a misnomer here. You're not subbing, you're recreating. This should be called recreate.
But
Why is
don't
it sub?
don't you kind of want to do that? I mean, because you're condensing the information every time you run through it, right? You're removing numbers and then you're removing special characters and then you're removing white spaces. So at the end you would have a completely new list, right, of clean data. But each one would have each step would be a different list, I guess. That kind of makes sense the way I'm thinking about it.
When you're learning how to do it, definitely start off doing it this way, for sure, right? But ultimately, when it's time to refactor, right, just do it in one because it's just more efficient code. if you're doing this as you're working through, please do it this way as you're working through the lesson. But when you're done with it, refactor your code and try to make it as optimal as possible. I'm not saying that this is bad, just be mindful that you understand what this is, right? That you're running it 3 times. That's the only thing I want to emphasize here. Make sense? Did I delete something? I felt like I deleted some code. Yeah, I did. Does everyone understand that? It's a pretty simple lesson here. Just making sure that you guys know that. Definitely do it like this when you start off, but remember, this could involve just in one. That way you don't have to iterate through the entire string multiple times and then recreate it multiple times. No point in doing that. So that's the first thing there. Noise removal, you know about tokenization, removing stop words or filler words, POS tagging. POS tagging is an interesting one. Did anybody get to this? I think a couple of people got to it on Thursday. Did you or did you not? I don't remember. Okay, cool. If you got to this piece on Thursday, you're gonna have to unpack tuples. And remember, you can unpack tuples by just doing like forward tag in whatever the thing is, like tokens or whatever. You're gonna unpack it this way, right? And then you can grab the word in the tag in the token. Token. There you go. You can do it that way. Just an easy way to do it. Tacking, stemming, and lemmonization. Talked about chunking. Number 7, actually 6 and 7 are kind of hard. You're going to have to traverse a tree. When you get to 6 and 7, actually, I'll probably bring everybody back to kind of cover this piece when you get here. But see if you can just get to 6. And then we'll cover the last little bit together. Make sense? We'll see if someone has a good one all the way up to 5 or 6, and then we'll see if we can close 7. Because on 7, you're going to get what you think is a list. It's not really a list. It's a tree. And the reason you get a tree, does anyone know? Because a tree is hierarchical, and that's how we organize our data. So the computer can understand, or the machines can understand the importance of words. Because ultimately, not all words are weighted the same. Not all words in the English language have the same value. Some words are more important than others. Make sense? Okay, cool. So let's just try to get to 6 at the very least. I'm gonna stop right there. I'm gonna pause the record. We're gonna start another couple seconds. Actually, we're gonna start now, even though people are trickling in because I started the recording. Oh well. Okay. How are we doing? How's it going?
It's slow. It's a lot of flipping back and forth. Especially I'm on one screen today, so it seems slower, but it's making sense.
Okay. Good. Anyone else?
One thing about, I think, step 6, it took me a minute to realize what was happening, but there's a pretty print command that's trying to do like ASCII art. That thing will crash your freaking computer. Like your terminal will crash if you try to run the entire novel through it. So I ended up like shrinking the sample size because I didn't know what it was doing. I just copied and pasted it in and it just kept not working. But then I saw it was actually working on something in the background. So I finally just crashed my terminal and then took a step back and was like, okay, I've got to do something. So I limited the sample size and it finally worked. But that's about where I'm at. I'm in step 7 now. And then I finally realized what you meant about the tuple thing as well. That's what I'm kind of trying to figure out.
Logan, that was full of a lot of really good information. I Moby Dick's got to be like 1,000,000 words or something. I don't know. Really big. I purposely didn't mention it, hoping that someone would figure out, hey man, maybe I should just use a sentence or two to get it up and running, and then I can comment out the rest. But good job. Awesome. Very good. I just kind of want to walk through just briefly before I cut you loose again. Just in case you're stuck, I'm going to just pseudocode this. When you're done with this, you're just going to have what exactly? Just one file, right? So this is kind of where you should start off with. I know I didn't really clone the read. Well, did I? No, I didn't. I just created an env. I'm importing the stuff that I need to import, but just pseudocode here. What would be the first function that I write? It would be to do what?
Get rid of all those special characters, extra white space.
Oh, you're getting there, but that's actually number two. Some kind of def clean text function, right? You're gonna have this, right? But first you need to load the data, right? So def, I don't know, load data or something. Load data, something like that, right? So you're just gonna have probably a file that's 200-300 lines, right? It's gonna be load data. It's gonna be then clean data. Awesome. What's gonna be the third one? Keep it consistent, and we can tokenize data, right? These are all functions that are going to write, and these three are actually pretty straight, right? And then you're going to write which one? Remove what?
Stop words.
Yeah, filler words, stop words, whatever, stop words, right? You're going to have this function, right? That's it. That's how you start. Those are your first four functions, right? You can obviously print after all of these, right? Start here, print. Hey, are you loading the data properly? Hey, print. Are you cleaning the data property? Is that what you expect, right? That's why it actually helps to start with a small sample size. You can see it in your terminal quickly, right? Print. Is it tokenizing properly? Sweet. Hey, did you remove the filler words? Cool. Awesome. Then you can get to the complicated stuff, right? Five. Five, this is where you start getting kind of complicated, right? Now you're tagging. And you do, sorry. And then you do the same thing, right? Just print after. It's just one file in a virtual environment. That's it. Let's go. Oh, did I just enter a shell? Oh, whatever. Doesn't matter. I wasn't even using it. That makes sense?
Control D.
Yeah. I just gave up on it. Panic. Does everyone understand this? Does this make sense to everyone? Just take it step by step, just like I did here. Pretty straightforward. Print after every single one. And yes, if you haven't already figured that out, please don't use all of the Moby Dick text. Please just use a very small portion. You don't have to use one line, you use a paragraph, but that's enough. That's more than enough to finish the assignment. Make sense? Yes? Here, I'm going to pause the recording here because I don't want this recorded, but I'm going to give you a perfect example of this. Let me pause the recording here. I'll go ahead and start the recording. How do we do? I think there's at least 2 or 3 people that got really close to finishing. How do we do?
Yeah, just still on step 6. I was talking to Nick and he mentioned about the lemmatization not affecting I think capitalized words, like the first word in a sentence or a proper pronoun or a proper noun. So I had to put a dot lower method somewhere in my lemmatization code to resolve that.
Which really should have been done at what step?
Just prior to probably the noise cleaning step in general.
The normalization, but close enough before where you got. Good. We're so step 6 is a little tricky. Did anyone figure out the trick to step 6 by chance? I don't want to give it to you unless no one's got it. Step 6 is actually, it's easier if you do it in 2 functions, not 1. Is everyone trying to do it in 1? I'll post it right after this. I don't want to take up any of your lunch breaks, but I'll just say this. You need to know what kind of word it is before you lemmatize it. Is that the word lemmatize? Lemmatize? Whatever. You have to know, is it a noun? Is it a verb? What is it? That's going to matter. So I would do it in 2 functions. I do get the tags and then lemmatize it. Sorry. I keep thinking lemon. I don't know why. And then I would have a lemmatize function. So I do it in 2 functions. It's going to be easier. Your lemmatize function is already going to be nested. So you're going to have nested loops there, right? So what they call a helper function, do a helper function, and then do your loops in the real function. So 2 functions for step 6. And then step 7, you can just do it in 1, I think. Yep. Yeah. Step 7, just 1 function, step 8. I would argue step 6 and step 8 are probably the hardest. Does that help? I hope that helps. No one said anything. Okay. Through this process, this Moby Dick assignment, what are you learning to do right here? I know there's a lot of technical jargon in the AI ML unit, but what are you actually learning how to do here?
Thinking
And
through the project from start to end.
yes, think through the project start to end, and you're doing well with data.
Manipulating it, making it do what we want.
That's it. That's all you're doing. Right? Granted, some of the terminology is a little abstract, and maybe we don't fully understand it just yet. That's super understandable. This is all very new to many of us. Totally fine. But ultimately, you're just leveraging libraries that other people built, right, to accomplish a goal. You're just manipulating data. That's all you're doing. Taking an input and saying, hey, this is the output, and trying to build out the algorithm. And ultimately, when people say algorithm, they just mean a step-by-step process to how to do something. That's it. There's really nothing more to that definition. That's all it is. It's just instructions, right? People like to say algorithm because it sounds fancy, but they're just instructions, right? Just really not that much different than when you buy something at IKEA and it shows you the cute little pictures and you spend, your whole Saturday building a TV stand, right? No one's done that? That's a joke. That's why you guys can laugh, man. I know you guys have done that. At least I have. Anyway,
It didn't take me all day though.
Why does it always take me all
Shots
day?
fired. Little faster.
It takes me all day, all the damn
We
time.
just go to IKEA for the meatballs.
Hey, I think I read, I haven't been there since, but I think you can order like a mountain of meatballs, like a family size portion. Look into it, like 100 meatballs or something. Anyway, I haven't been there since, but anyway, question. We're about to go to lunch. We're going to come back in your groups that I posted at 1 p.m. Do you want me to post a snippet of the code that you should have for the first 5 or 6 steps? Would that be helpful?
I think it'd be
Yeah.
useful just to
Yes, for me, it would.
Okay, I will post the first 6 steps here. I won't post the rest for the simple fact that the Musketeers assignment, guys, is more or less the same thing. So if I give you the last steps, then there's really nothing else to do. Make sense? So your code, when it's finished for this one, should work for Musketeers. It doesn't really matter. It should work for both. All right, cool. I'll post it. Go on break. We'll be back in your groups at 1 p.m. and I'll post a little bit of this code snippet in Slack. Dang, forgot to record. Sorry, guys. Anyway, all right, so this is what we're going to do. We're actually going to cut out a little early. We're going to stop class at 3:30. So we're going to go back into our breakout rooms and see if you guys can close 7. But after about 20 minutes or so, give it a good 20-minute shot. See if you can finish 7, those of you that are really close. If not, I'm going to go ahead and post it on the Slack channel. We'll come back for a quick debrief at 3:30, and then we'll call it. Sound good? I'm going to pause the recording there. And I just want to bring you in to wrap up for the day. Let me check the rooms. I think everything's closed. This is everybody, I believe. Things closed, yeah. All right. We can get started. How did the last little session go? Anybody close out 7 by chance? Even with the help, even if you had to peek at the answer?
Yeah, I was able to get it all to work.
Awesome. Good job, guys. Anyone else? Oh, nice. Nice job, Dan. Oh, wait, you just chimed in. No worries. If you haven't, if you have a little extra time and you want to try to finish it, definitely worthwhile. After doing Thursday's lesson on text pre-processing and today's lesson on natural language processing, you should start to realize that cleaning and labeling the data is really what percentage of this task.
Like most of it.
Yeah, most of it. Having clean, labeled data, right? It's literally most of the work. The last little piece is the vector math part, something that computers are exceptional at, but they can't do that piece until we clean and label the data properly. I think I mentioned, I think I was calling him Alex, but I just pulled him up now. But I think I mentioned Alexander Wang. He was a founder of Skill AI, and his entire AI company was built on labeling data for LLMs. That's it. He is the youngest, I think, self-made billionaire in the world at 25 or whatever he was when he founded it, and he sold it to Facebook or whatever. Now he leads their super intelligence lab with a couple $1 billion pay package probably. But that's all his company did, right? So you start to realize that this idea of cleaning and labeling data properly so the LLMs can function like they're supposed to is actually really powerful and actually really, really, really important. So hopefully you're starting to understand that and come to that same conclusion. Yeah, he found a very niche problem and created a startup that grew very, very quickly. So yeah, that's really the main thing that I wanted to bring up on this debrief session. And I will leave you with this little story from work as well. Recently, a little while ago, we worked on a little problem that was similar to this. Not really AI or ML focused, but we ran into a data labeling problem. Here's the scenario. A certain company had a bunch of accounts that were from the old system, and they had transferred to a new system, and they had a bunch of new accounts. Now they were trying to not have 2 different databases. Yes? Old accounts were on the old database, new accounts were on the new database. Be super dope if everything could be in one place. Yes? There's a big problem. Big problem that a lot of the metadata, the tags, didn't exist in the old data. And it did exist in the new data. And the new database wouldn't play nice with the old data unless the old data had all the same tags. So guess what we needed to go do?
Clean it and retag it.
Yeah. We needed to process all the old accounts give it attributes that it was missing. And if it didn't have an email, give it null because a new database could handle that. But it could just not exist because that wouldn't work for the new system. So what did we do? They processed a ton, pretty much their entire old database, tagged it, cleaned it, uploaded it into the new database, relaunched their application, and now everything plays nice. That's not an AI ML problem at all, right? But that idea, right? It's the same idea, right? And you might one day have to do a problem, solve a similar problem, right? Those problems are super, super common. Yeah, that does happen, Dan. Dan just gave another example. Does that example make sense though? Yes? Something as silly as, hey man, those guys, when they created the accounts, email wasn't a thing. And if you remember, like pre 1995, it really wasn't, right? So all these really old accounts, in the grand scheme of things, aren't that old, right? 30 years, not that old, right? But in internet time, that's a ton, right? So we need to reconcile all those old accounts into the new system because you don't want to lose the data, right? And now data is incredibly powerful, right? Because we can do a lot more with it outside of just selling it, which is what a lot of companies do. Anyway, I'm rambling. I hope you got something out of that. There's one more week left of AI. Some of the stuff coming up though is like a little bit more dense than what you've covered so far. So buckle in. The AI hype train continues. Okay. Have a wonderful night, guys. Enjoy. I guess it's a holiday. Whatever. Just don't try to piss off your significant other.